Okay, we went ahead and did a movie already for problems 1 through 10. Let's look at 11 through 20. So for problem number 11, you have this long problem here. I'm not going to read through the whole thing. You have the review. And you are asked to find what we're doing in problem number 1 and in statement number 1 and what we're doing in statement number 2. You can even look at the choices if that helps. A says substitution property of equality, C says substitution property equality, D says substitution property of equality, and 1 says simplify. So looking at the answers, obviously I think that my choices, we didn't simplify that, we substituted. Now, dropping down to this point, we had 10 equals 2W. We ended up dividing on both sides. So that is the division property of equality. That is why number A is 11. Number 12 is again a proof with 2 missing steps. Okay, so once again from number 1 and 2, so they said that EG, they told us, is equal to FH. Then they went in and said that EG is equal to EF plus FG. That to me looks like it is segment addition postulate. So it can't be A and it can't be B. It can either be it can at this point either be C or D. Then after I do another set of segment addition postulate, I'm told that EF plus FG is equal to FG plus GH. That to me would be transitive property of equality. Okay, but they don't have transitive property of equality. They have definition of congruent segments or substitution. So I'm not loving this right now, but I'm going with that as the answer because I really would like this to say transitive property of equality. So I just want to look. There is the transitive property of equality here for B, but then it would say 1 was substitution. And as we've talked about in class, sometimes the answer would be substitution. Transitive property of equality would be a better answer. It's not there. That's not one of our choices here. So I am going to go ahead and have to go with answer D. But I do admit I don't love that answer. For number 13, once again, we have to fill in these 2 properties. So the measure of angle PQR plus the measure of angle SQR is equal to PQS. Notice this is not really a proof for just justifying our steps. So when we put those together, that's definitely angle addition postulate. So either A or B. We're not using any protractor here. So then when we look at this next step, D, in order to get the 2x equals 90, we're subtracting 10 from both sides, so it is subtraction property of equality. So 13 is B. 14, identify the hypothesis and conclusion of this conditional statement. If tomorrow is Thursday, then yesterday was Tuesday. So I want the hypothesis is the beginning part. If tomorrow is Thursday, that's not it. Oh, B says tomorrow is Thursday, and D said tomorrow is Thursday. The conclusion is yesterday was Tuesday. Yesterday was not Tuesday. I want yesterday to be Tuesday. So the answer is 14 is D. Okay, that's the end of that page. Moving along to problem 15. For the conditional statement, write the converse and the biconditional statement. So if sides A, B, and C, then A squared plus B squared equals C squared. So for the converse, I'm looking for where it just says A squared plus B squared equals C squared, then the figure's a right triangle. So I need to start with A squared, B squared, C squared. That one does not. This one starts, if A squared plus B squared equals C squared, then the figure is a right triangle with sides ABC. That could work. If a squared plus b squared equals c squared, then the figure is not a right triangle. No, there's no knots in the converse. And if a squared plus b squared is not equal to c squared, no, the knots would come in the inverse. So let's look at this one. A figure is a right triangle besides a, b, c if and only if. So it is 15b. Number 16, for the following true conditional statement, write the converse. If the converse is also true, combine the statements for a biconditional. If x is 8, then x squared equals 64, okay? So the converse of that would be if x squared is 64, then x is equal to 8. That's false because x could be equal to, right, negative 8. Because a 64 negative 8 times negative 8 is also 64. So the correct answer is 8. Number 17, if possible, use the law of detachment to write a conclusion. So if x is equal to 3, then 3x minus 4 is equal to 5. So since x is equal to 3, then we are just stating the obvious. 3x minus 4 is equal to 5. Number 18, use the law of detachment to draw a conclusion from the two given statements. If two angles are congruent, then they have equal measures. So, angle P and Q are congruent, so angle P, the measure of angle P, is equal to the measure of angle Q. So that's kind of what we have in proofs where we say, well, wait, we just said they're congruent, they're also equal to. That concept would be the law of detachment. 19C, I said don't worry about the truth table. And 20, short answer. So the first thing we do is add AOB and BOC. That is the angle addition postulate. So then we put in 2x plus 6x minus 3 equals 150. And that is substitution. Okay? Now, they've been telling us a lot that we have distributive property when we don't really have it, but in this case, we're multiplying 6 times x and 6 times negative 3, so that is definitely distributive property. For the next step, I would say combining like terms. The book has simplify. Either one I would count as correct. Now we're adding 18 to both sides, so you would spell this out, but the addition property of equality. And when I divide both sides by 8, I get 21. That is the division property of equality. I know that you guys are very concerned about the proof on this test, and I will put out proof examples, but I think as you can see, the examples that we did here on the test are really very straightforward.